Today, I will try to make this webinar for you that we prepared among the next 40-45 minutes, so that we can leave the latest 15 minutes for Q&A, if that's okay for you. We prepared for this session a nice agenda, so that it's basically based on 4 points, which is basically an introduction of what the digital twin of cost is and how important it is for the auto industry. I prepared a high-level overview. Then I will go straight. The big body of this webinar will be the live demo, and then trends and benefits. Yeah. So let me go through the first step. This is only a couple of set of reminders, and some of you. For some of you, this might be a little bit new. So the digital twin, what it is, is like a virtual representation of a physical product or process that is used to understand and predict the performance and characteristics of what is going to happen in reality. Yeah, so we have here digital product, digital production, and performance. And what we try to do in Siemens, we try to help the customers to reach and have a full copy of what is going to happen in reality. And for the cost, it's totally the same. Yeah. So what we do is we try to predict and simulate and try to optimize the product and the production systems before investing in prototypes and physical assets. Yeah. And that happens into the real cost at the end of the day. Yeah. So for this, the digital twin of cost, what it is and how we realize it. So basically, we need these 3 steps: the digital product, the digital process, and the digital plant. Yeah, normally all this information, when we combine them, yeah, it forms digital twin of cost. Yeah, so it basically is a cost estimation based on mirrored data set from other sources. Yeah, and this we do combining different sources. Like it could be a PLM system. For those who doesn't know, PLM is product lifecycle management system, where you have like the BOM management, CAD management, and many other features where you normally store the bill of material, the bill of a process, geometries, etc. Yeah, so you want this information to go through your solution. Yeah, and currently you might say, okay, but I don't have it in the PLM. I have it in another enterprise application, like annual volumes or purchasing prices or material prices. Yeah, and other type of costing information. We want a direct integration with this digital twin. Yeah, and is of course we don't forget about actuals. Actuals is normally in ERP systems, yeah, in enterprise resource planning, yeah, where we have the projects that we have won in the past, and we might say, okay, I want to reuse a product that it's already in production, yeah, but I would just want to make a copy, change a couple of attributes, yeah, and the quote should be done, yeah, and of course. I have also my cost centers, my cost rates, yeah, my activity rates, material prices from my own company. So I want to reuse them for my digital twin of cost, yeah. So this will be the perfect scenario, right? And of course, perfect for all will be that it's not only estimating products, yeah, as a physical parts that we will produce, parts or assemblies that we will produce, but also the tools, yeah, the one-time investments for tooling, and also the dynamic study for the total lifetime of the product, yeah, not based on a static year, but this is what we call profitability, and it should be hosted in the cloud. And I want the same methodology so that my customers and my suppliers can talk in the same language, yeah, in the same methodology, so that we increase transparency, yeah. So for us, our vision, the digital twin of cost solution should be looking like this, yeah. And we will explain why, because the first challenges we see that in all, not only in the auto industry, but most of the industries, is that there are three types of perspectives. Yeah. So there is the first perspective where you say, okay, I view this part or this assembly, and it should cost, depending on raw material, depending on the process I will put, depending on the location I will produce it, yeah, etc. All this BOM, I will do the should cost of this part. But then there is another view. We'll say, okay, if this part is going to be produced, the one-time payments, the capex and the tooling should cost this much, yeah. And then there is a third view, which is normally above here. The profitability and the controlling will say, okay, the cost center rate of this production system based on my predictions, the occupancy and so on, the cost center rate will be, yeah, and this data needs to be across usage, yeah. And we say this because obviously in the greenfield we have various use cases, yeah, and all these have to be communicated away to customers and suppliers. Therefore, we've built a map here where we have like 5 type of, maybe there are 6, yeah, if we grab one for tool costing alone. But basically, if we start from the bottom left here, we have the engineering department, where they are obviously in charge of the design, yeah, in charge of developing the CAD models, whether it's electronic CAD or mechatronic CAD, and then maybe sometimes depends on the size of the company. They do also take care of consideration of the tool costing. Yeah, others are purchasing department, where they are responsible for the should cost, the supply chain, the tool costing as well. Depends on in which company. They do one-time calculations for different commodities. Yeah, we also have the cost engineering, where they do the new product development introduction. Yeah, so I will want to develop this product. How much will it cost based on this design? Track changes throughout the lifetime of the product, not just in the development phase, but earlier on when even I don't have a CAD model. Yeah, I need to start costing when I just have a conceptual idea. Yeah, and based on requirements, what should this cost? Yeah, and then we have also the controlling department, finance, where they manage the profitability, cash flow, and KPIs of the products they launch. And then we have the sales or the buyers, where they just launch cost breakdowns, negotiate with suppliers, customers, and manage the prices. Yeah, normally there is a breakthrough these 5 or 6 stakeholders, where they just work around with very innovative and very high homegrown cost models. Yeah, but that normally trends into mistakes. Yeah, because the data is not trespassed very well, and the data is breakthrough sometime because of manual errors. Yeah, and then we just say, okay, the solution is connect the silos, yeah, to increase the accuracy and speed. Yeah, and for this we have the vision of integrating everything into the same solution. Yeah, so this is our main idea, and the benefit is to enforce consistency of data and methods and objectives. Yeah, improve the transparency of cost to all stakeholders. Yeah, earlier increase to the cost fidelity and significant advance in process efficiency. Yeah, and for this we go into explain all the use cases. Yeah, because I'm aware that some of this audience might be in one of these or part of several of these use cases. Yeah, for example, target costing. Yeah, where they want to calculate complex assemblies and versions accurately and quickly. Yeah, and they want to quickly calculate. Yeah, and the controlling department, the finance, wants to ensure the profit targets that are met. Yeah, and the purchaser or procurement. Yeah, they want the cost-based negotiation with suppliers. Yeah, and then of course we have our sales, buyers, commercial, where they just want to speed and accuracy, and of course they want to have the cost transparency and understanding of all the cost breakdowns that they will report to the suppliers and customers. Yeah, and they also are the engineering, where they normally handle the design to cost use cases. Yeah, where they have they want to calculate the impact of concept changes. These concept changes might be on change of material, change in design, change in location, change in cost factors. What happens if I change any attribute? What happens if I change my plant? Yeah, and also the tooling, where they just want to calculate, okay, what is the speed I want to calculate my tool cost with the speed and reliability. Yeah, so all these are the use cases that there are present in the digital twin of cost. Yeah, and we wanted to present this to show you that the demo will have all these 6 use cases, so that we don't leave anyone away, yeah, from the digital twin of cost scope. Yeah, so for this we will go to the next, which is how we can help you to address these cost challenges, yeah, and achieve this state. So very simple. We have a solution which is called Teamcenter Product Cost Management. Is a solution based on 3 main areas: product costing, tool costing, and profitability. Yeah, of course supported with a centralized database, which we have here on the middle, which is master data connected with other enterprise applications. Yeah, but also critical reference data for brownfield calculations. It means that we are called Teamcenter. Yeah, we can connect to any other enterprise application. Yeah, we don't mind which one. We have open APIs via web services, and we have a huge master data that will support in our cost engineering should cost analysis. Yeah, and for this we are #1 solution in the market for cost engineering. Yeah, so it's been like this for the past 3 years, and we are very glad to have this statement in here in this board. So let's start with product costing. And this will be a brief explanation how we handle product costing in our tool. So basically, the calculation principle is as follows. So basically, we begin with a bill of material, whether we create it or bill of process, where we can create it or simply import it, yeah, from an external resource. Yeah, with parts and components, raw material, manufacturing steps, for any situation. Yeah, this will apply for both made parts and buy parts. Yeah, so basically, then we create our first variant. Yeah, the first variant, we add a specific design available. We select the manufacturing location and volumes, and we add the manufacturing parameters for each operational, like a machine, cycle time, yeah, etc. Yeah, and then we can have additional variants, yeah, unlimited. But here in this slide we can see 2, and then the cost engineering will decide based on which are the best. Yeah, maybe I have a different machine, maybe I have a different plant, maybe I have a different shape. Yeah, not always the 3 changes. Yeah, but we can run any number of additional variants. Yeah, and can be quickly created and run a sensitivity analysis by making changes to any of the cost drivers. Yeah, and this capacity we can save up to 25% of our cost by selecting the right variant. Yeah, based on the most optimal assumptions. Right. So this is the current calculation principle. So how do we achieve this? Yeah, first we import or we create the specific information, which can include 3D geometries. Yeah, here I put 3 different icons. If it's a casting, if it's any sheet metal or molding or a specific part, yeah, we can create the geometries, import them from any PLM associated system. And then we integrated with integrated CAD models allows the system to identify the dimensions like weight, surface area used in the calculation for each individual part. Yeah. Secondly, once we have the BOM and the BOP and the geometries associated to each part, we create the process route. Yeah, where we can then in each process route we can identify if this process is green, therefore we make the part, or is blue, therefore we purchase this component. Yeah, and then obviously based on this we have different material rates, labor rates, machine rates, and plant rates, overhead rates, if the part is in-house manufacturer or external manufacturer. Yeah. So this is why we mean the digital twin of cost is having a real impact, because matching these three, having all these three informations together gives us the digital cost model. Yeah, of course you can compare all different type of scenarios X, Y, Z, where allows you the user to compare different scenarios and to select the most optimum variant for the solution for this business case. Yeah. So this is how we bring the digital twin of cost together, right? So next thing is the leveraging this information. Yeah. So we've seen a very simple map. Yeah. I want to integrate PLM, some other enterprise applications, some other ERP applications. So we start here with the product information. Yeah. Where start normally is the sign by CAD or ECAD, yeah, where systems where during the development phase of the product, and those normally should be synchronized with the PLM data, yeah, where this PLM handles the BOM, the CAD management systems, where these BOMs and BOPs are stored and controlled during the development phase of the product lifecycle. So here I put the shape search, which I think is important, of course, for the costing people, which enables the users to search on products of similar shapes by entering the geometry you are looking for as a surrogate. Yeah. So this, as indicated before, should be synchronized with our costing system. Yeah, or costing platform, where we currently have open APIs that allows us to import all the bill of material and bill of processes of the corresponding geometries from any PLM system. Yeah, or costing should also have the new feature to cost tool, which aim for tool costing and check the part design in detail. Yeah, and for the other end items is the actuals. Yeah, so we might not want to synchronize the information from the left side. We want to start from a reuse a project that already is in production, or maybe we have even developed and final and ended the project. But this includes the plant information as well, the material cost, internal hourly labor and burden rates, and as well as reuse existing estimates that have been stored in the master data for quick alignment to import the bill of material. Yeah. In addition to this is our BI tool that can report and automatically synchronize all the costing we've done in our costing solution, and of course this will apply real-time information. Yeah, and finally, Siemens has also introduced a new low-code application. Yeah, that which can be used to create simple views of our cost models, and search data can make changes from a mobile or a tablet phone. Yeah, as an example here, I put a scenario whether we can synchronize an ECAD and CAD tool. Yeah, together we import the bill of material and bill of processes into our PLM. We search for similar shapes in the PLM, whether this part has been produced or purchased. Yeah, a lot of non-relevant parts can be found here, and maybe we have purchasing prices, yeah, based on the ERP prices, and then we import the full bill of material in costing, yeah, where we run our cost models, we synchronize it with our BIs, and we can even make an app, yeah, for this costing that we run, yeah, making available the information for the buyers or the commercial people live, all this costing that we are doing, yeah. So this is the full map for what I represent as digital twin of cost, yeah. So and what should happen. So of course, this product costing should not be a standalone tool. We also support it with integrated knowledge data, knowledge domain, yeah, which enhance our costing capabilities. And this is what the out-of-the-box data content that we provide. This does not mean that this data content cannot be configurable or expanded with your own knowledge. Yeah. So, for example, we deliver country data for 67 countries. Yeah, with labor rates, energy costs, floor space, interest rates. But you can add your own supplier data. You can add your own customer agreed rates. Yeah, you can add your own internal data in this platform. Yeah, so it enables you to add as well your own rates. Yeah. As well as substances. We deliver more than 1,400 raw material types, yeah, with properties, with technical details like density, molding temperature, yeah, for then our cycle time calculators will reuse. Then we have machines, more than 4,700 machines. We are trying to elongate this list every time more, adding more value to our customers. So we have like all the, not only acquisition prices, but all the technology details and all the technical details. Yeah, this machine will occupy so much floor space. This machine will have this energy consumption, yeah, etc. Yeah, so we will provide a long set of parameters for each single machine. Yeah, and then we have more than 700 reference processes. These reference processes, some of you call it cost models. Yeah, where it was born traditionally from the auto industry, is well taken, and for all type of commodities. Yeah, and we have last but not least the cycle time calculators. Yeah, for all this type of different kind of technologies. Yeah, and also users are being able to create their own cycle time calculators. For the cycle time calculators, we have here these cycle time calculators out of the box. Of course, you can integrate, most importantly, your own cycle time calculators. But here we have, as you can see, forecasting for injection molding, for assembling, for machining, pick and places for PCB boards, laser cutting, chamber loading, wire harness, welding, and stamping. Yeah. So all for these cycle time calculators are for the users to support them with theoretical cycle times based on the properties of the geometry and the material used by the product. Yeah. So all this will vary depending on the machine you select. Yeah. You can have the same product with the same geometry, with the same substance, but two different machines delivering different cycle times. Yeah. So all this can be checked. And as well, we provide the technologies, yeah, the cost models, the reference data. This is just for information. This is our own library, but most important message here is on the bottom for me. Users are able to create their own technologies. Yeah, that doesn't mean that we will keep elongating this list for sure, but most of the customers that are using this tool are tuning this library for their own needs and creating their own traditional products library, yeah, by commodity or by product line or by any system, any way they want to address their information, yeah. So it's very important, and I will show during the live demo this library. As well as the next leg of our product, we have tool costing, which is a very nice tool to estimate cost of our one-time payments. Yeah, and the tool costing is much more parametric in nature. Yeah, the objective is to significantly improve the efficiency in tool costing without a loss in accuracy. Yeah, so basically this is why we choose the parametric solution. In step one, you import the feature, the geometry. In step two, you only need to choose the profile and location. And step three, you click calculate, and the parametric solution will get the result for you. Yeah. Of course, this will need to select the technology and the tool build location but all the results and all this process with the parametric solution can be tuned and configured. Yeah. So we have a lot of parameters where the tool shops and the customers can put their productivity factors. They can align and change their labor rates. They can align and change the material prices so that the final result can be as accurate as possible. Yeah. And then, of course, here is just a view of the tool technologies we have here created in Siemens. And of course, we have customers which created many other technologies depending on the products they manufacture or they buy. Yeah, and of course, this is most important message. Again, the users can create their own tool technologies and profiles, right? So any technology that you don't find here, please feel free to contact us. We can, of course, demo and create a similar, a different technology for you. Yeah. So the last leg is the profitability. Yeah. Okay. Then we say, all right, this we calculated the product and the tool based on a single year. Now I need to calculate my full lifetime life cycle project, yeah, based on these end items, based on this product, which is partially manufactured in plant A, plant B, and plant C. And maybe I have five products which are the same but different footprint, yeah. And we want to configure the full P&L, not based on a single year, but based on 8 years, yeah, where you configure your own P&L, calculate the complete business, yeah. You can put the price dynamization, the material dynamization, the labor. So my labor is going to increase 2 or 3% every year. Same for material. My overheads are going to evolve drastically during the next following years. And we see how the cash flow evolves based on our parameters, yeah. And then we can drive a goal seek, yeah, based on different scenarios, and optimal, medium, and pessimistic, yeah, for example. And then we can compare multiple scenarios. So, for example, I can grab 3 or 4 projects I have for my supplier or my customer, and I can put them together to see the total profitability, yeah, based on these parameters I choose. So for this is our solution based on these 4 topics that we selected, yeah. And of course, the main message here is that product costing provides the enterprise-wide platform for creating and managing calculations, yeah. The first point, with a bottom-up calculation that you can read. And this approach is based on a detailed product structure, as we've seen, define the use case approach. And of course, we have the tool costing that customers can calculate and manage cost of tools, yeah, molds and dies, which are required for multiple technologies, as we have seen for the injection or die casting or stamping. And as molds and dies are complex in terms of design and manufacturing, with this approach, it will require a very deep knowledge of the users as well as very high effort in time, but not with this solution. Yeah, for that reason, tool costing eases the automated methodology with a 3D-based costing, reducing time a lot for the tool costing users. Yeah, and final, we have then the profitability, which allows the users to calculate the dynamic study, yeah, ensuring all data is traceable from the start to the end. And finally, we have the master data supporting all these reference data studies, yeah. And for this, we are adding always, since last year's, we're adding new capabilities, yeah, which we will show later in the live demo. For example, in product costing, we have the new capability of cost model integration. For the tool costing, we have a new feature to cost capability we will show, and the profitability, we have the open connectors with any other sources, yeah, such as BI, and for master database, we have new sources, yeah, so that whenever the message here is when you decide to go, if you decide to go with us, with Siemens, we will every 6 months have a new release with new features, yeah. And of course, most important message: this platform is standard, yeah. So therefore, I wouldn't call it even migration. It's very simple to go from one version to another, adding the new capabilities, yeah. So whenever these are available, we always launch a release letter with all these new features, yeah. But today we will see the live demonstration with these capabilities, and for this, I prepare this demonstration based on the 6 use cases, yeah. And I will go one by one, right? Maybe with a different order that we can see here, because I want to start from scratch and see how you will use the tool from the start to the end, yeah. I start from scratch, and I will send the offer to my supplier or my or my customer, right? So basically, we start with the target costing. Maybe I'll go then to purchase price analysis, tool costing, design to cost profitability, and cost reporting. Yeah. So let's start with the user interface. So most of you here are not aware of the interface that we have. So that here we can show you where are where to store calculations. So on the left we have the Explorer. Normally here is where we leave the reference processes in the knowledge domain. Here I have my own private folder where I can store my own calculations, and the public folder where I store my company calculations. Yeah, in this case is empty because we didn't start any calculations yet. So next topic on the board is where is master data. Yeah, so we can open the search capability that we have on the right side, and of course here we have a drag and drop. So defining what do we want to search, yeah, and which, if it's a part that I calculated before, if it's a project, or if it's a machine, a cost center, or a cost factor, like a hourly rate, rates, materials, overhead, substances, or work centers, yeah, going from customer-driven data, plant data, or supplier data, yeah. So this is a simple view of the master data search. And for example, here I will search for a cost factor detail. So I will drag into filtering, and I want to see, for example, can you show me please all my cost factor details for Germany, Hamburg, yeah? And this is the out-of-the-box provided data. So I can see here the hourly rates for 2018. I want to filter them by years, so I filter validity. So I have my years here provide, so I can see all my cost factors from one single year in this master data. Yeah, all these will be reused then for my calculation, right? Same as cost center, same as internal rates, right? So all these can be created, imported from ERP in case are your own cost factors, or can be delivered by Siemens in case of benchmark data for reference. Yeah. So this is the interface, what it looks like. Yeah. And now we'll go to the first exercise, which is target costing. Yeah. So let's start with design how to build a calculation. Yeah. And here we have let's call this key user. Yeah. We'll create new. And we see when we go to the public folder and we create new, we can either create a folder or a project. Yeah, so I create a project. And right here, when I right click to the project, I see in the middle always I have this functional view. I say, okay, I want to create a part, a tool, a geometry, development, or a profitability, or a variant cost. Yeah, so here I can create a new part. And now what I have new is the BOM view. Yeah, so the BOM view allows you, we call it the quick editor, allows you to create in a simple spreadsheet way to create a BOM, yeah, where we can create here raw material or a part underneath, yeah. So we can create a hierarchy, calling this steering, for example, from a bike, yeah, and so on and so forth. So I can create my own bill of material with, you can see here below the manufacturing steps and so on. So that now we have created my bill of material. I will basically create a manufacturing step, or I can select, okay, is this part make or buy? So the bike will be manufactured by me. So it's an in-house manufacturing part. Yeah, so I click accept, and you can see the icon of the part will change automatically. Yeah, and the behavior of the overheads as well. So next, I will add a process. Yeah, so this process can, next I will add my plant, and I will say, okay, I will manufacture this in Germany. Yeah, in my plant of Germany, I see I have 3 plants. I select the first one. Yeah, so that all cost factors from this plant will be applied from now on. And then I assign my cost center. Yeah, for example, I have here an assembly, and all this is synchronized with my ERP, so that I have my rates automatically assigned from master data. Yeah, I only need to assign a cycle time. I put 300, and automatically I get the price. Yeah, based on the overheads and so on. So this is how simple it is to create this BOM. Yeah, and you will say, okay, Eduardo, very nice, but what if I want to apply a maximum BOM and create a variant matrix? Yeah, I want to create a variant 1, variant 2, variant 3 based on 3 different scenarios. Yeah, for example, and here we have this capability of applying this variant matrix. Yeah, so that you can have a maximum BOM in your Explorer, or you can have imported it, yeah, or created it. So with this BOM max, with some different parts, maybe different designs, maybe these different parts have different footprint, yeah, where we can create new, and we can apply variant calculation. And of course, once this is done, the new landing page will open. And very simple way, I will just drag and drop my maximum BOM into the board. And next, I will drive my next 3 end items into the variants. Yeah, so I have an economy, a medium, and high end. And what I only need to do is to set up my product configuration here as wished. Yeah, and I can say, okay, not 1 but 2 wheels for every bike. Yeah, I will need 2 at least. And here, all the BOMs will be created automatically. Yeah, so this is a secondary way to create a BOM fast and easy, right? So we see this is the third way, the second way. The third, what if I want to import 1 bill of material, 1 bill of process, or multiple? Yeah. So this is an example using our own PLM. It can be any PLM. Yeah, it can be any other enterprise application. So I just do BOM import, and here I will show you in detail that we have different interfaces. Yeah, so we can import from Excel, or we can import from Teamcenter, or we can import from SAP. We can import from cost breakdown, or even import from another enterprise application. So here we'll only need to put the path number. Once the path number, it finds it from the system, you click on execute and the update behavior, and this will import the full bill of material. Here we have the mountain bike, and of course with all the hierarchy levels, and here all the geometries. Yeah, there is a huge list of geometries. All the geometries are linked with the path, and here we can start a quotation. Yeah, so the geometry will open directly in PCM. So this is the 3 ways we can create bill of materials. Yeah, and we can do internal calculations. This bill of materials can have make parts, buy parts. Yeah, but of course the main benefits here is that manual searches and discussions about what is correct, what to apply are omitted. Yeah, and obviously transparent and always up-to-date calculations. So you don't need to bother if your master data is updated or not. Yeah, because that the system will do for you, and also reduce time in consuming tasks. Yeah, data search, validations, reconciliation processes. So you have a huge time savings in this NPDI process. Yeah. So the next use case is, okay, Eduardo, what if I want to purchase one of these items? Yeah, in the bike. So we have the purchase price analysis use case where I will do for the brake. Yeah, in this case, I started my BOM from scratch. I created it, and I will create a geometry for die casting, for example, for my left or my right hand brake. Yeah, so I import the geometry here. You can import it from your PLM. Here you can import it from your local environment. In this case, for this demo, I call it brake, and I only need to do 3 clicks. Yeah, so that I can export the basic parameters, the molding direction, the basic, and the manufacturing dependent parameters, and I only need to select a substance, right? When I select a substance, the weight is calculated for you, yeah? And this is the final weight of the component, right? So I only need to open the brake, and the landing page will open for me right? And I only need to link the geometry that I just enhanced in the system, right? So this is the first view. Then we go to basic data when here we make changes for the plant, region, customer, supplier, etc. So when I just choose the location, I just select here the location. I can select which supplier is going to do, or which is the annual volume, the shift model, etc. The next thing I can do is I can open a mass calculator for material. Automatically, a mass calculator will open, having all the data synchronized. Yeah, here I only need to put parameters like the sprue overflows, material price is synchronized with the master data, and overheads are below, and it can be created or modified. Yeah, these overheads are totally configurable. And next is the manufacturing route. Yeah, so I can go to my own library and say, okay, how is a die casting part produced? So I will just drag and drop very two simple manufacturing steps. Yeah. In these manufacturing steps, let's remember inside there is all machine and equipment and all the operators and the tooling. And then I want to include other 3 manufacturing steps, yeah, like end final process steps. I will just drag and drop them and have a complete manufacturing route, what I believe is good for this part. And then I just open the die casting and I open my cycle time calculator here, yeah, for die casting. Here, automatically, the geometry and everything and the machines are synchronized. It tells me, okay, this geometry with this surface, with this substance, will have a champing force of 800. But the machine you selected is much way superior, so there is no error. So cycle time should be 34 seconds for this, yeah, based on this machine. And then we can see the machine hourly rate with all the acquisition prices. All the yellow boxes are location data based on the country. So every machine will have a different machine hourly rate in different locations. And then we have the labor rate with total labor burden. Yeah, the tool costing will see it afterwards. And now I only need to check the overheads, which can be also synchronized from the master data. Yeah. So at the end, we could have done this from the Excel spreadsheet view that we have here. Or we can do it in the tabular form where I don't forget any type of inputs. Yeah. So either of the 2 ways are good. Yeah. Friendly reminder: this BOM view can be editable. Yeah. All the columns I edit myself. You can edit your own columns. You can edit the names of the columns so that you can have different views: one for purchasing, one for target costing, one for design to cost, because maybe you want different columns in each different view. Yeah, this what allows the key user is to, of course, save time by importing the 3D data. All the technical values are transferred directly, yeah, to the part and the cycle time calculators. The use of the cycle time calculators and mass material calculators sets uniform standards and avoid mistakes, yeah, from the users. And this purchase price analysis enables you the possibility to adjust the costing for the supplier and makes market prices are easy to argue, yeah, in a transparent based on standard prices, yeah. So all this reference data is enabling all these brownfield calculations, yeah, which enables to save from 5% to 16% to some parts in single projects, yeah. So then the next use case, I'll go a little bit fast because of the time, is tool costing. So this tool costing is based on parametrics. So we'll just start. We have another key user you might have recognized. So this key user opens the technology. Okay, this is a break. I'll choose the die casting and I'll open my tool costing. Yeah. So we see this is the landing page for the tool costing. Very simple. Here you can add file attachments, pictures of the part, and in the geometry we will link the 3D file. Yeah. So as we did in the product costing, we link it and we click on analyze. This feature to cost is based on our NX tool, much more precise for calculating extra analysis that are not done in the product costing 3D viewer. So here we will select feature to cost molding. And in this, we will calculate undercuts, ribs, and opening inserts, yeah? So here we will set up the right molding direction, yeah? It didn't get it right the first time, so I can change it, and I can just click to full analysis, and the calculation will be completely done for you, yeah? So here we have all the part volume and part information, but most importantly, all the undercuts are shown here based on the orientation. So I can turn the part. Everything highlighted in orange is undercuts. All the ribs, yeah. So I can see here there are some ribs in this part, and the dimensions and the length. All these are tool cost drivers, yeah, tool costing drivers, and the opening and the inserts, yeah. So we can see here in orange the opening and inserts. So when I click OK, I go back to my product costing. It tells me as there is direct integration, if I want to import all changes based on the 3D analysis, yeah. So I have here all my opening inserts, undercuts, and ribs and ribs areas and embosses, yeah. So of course here I can select, okay, this is what is the part finish, yeah, the industrial polish or a grain, or depends on what is the part going to be placed in the end item. And here I go for my tool specification, and here I only need to change the tool profile. Right now, out of the box is the cold chamber, but I say, okay, this will be a hot chamber, and I just need to select, okay, where is the tool shop side? Yeah, so I want to select my tool shop side, and I will say, okay, this part will be produced in Germany, but I will buy this tool from Portugal. So please calculate what should be this tool cost for Portugal, yeah? So first calculation gives me 15,000 euros, yeah, for this, but I want to set, okay, 2 cavities, yeah, it's very small. I can do a multi-cavity scenario, yeah. I here say, oh, it's now 20K for 2 cavities. That's maybe more cost optimization, yeah. I can test then with 4, 8, 16 cavities, etc. Yeah. Here we have the bill of material, cost breakdown, and functional structure, where I can drill in, drill out for details, and I can synchronize this tool costing with my die casting. So I can just say, okay, I want to delete this, and I want to synchronize my tool cost with my fixtures, with everything in the calculation, the product costing. Yeah. So I fully synchronize this tool costing with this part costing calculation, yeah. So yeah, thank you, Jay, for the for the notice. So this obviously allows you to capture all cost drivers, ability to drill down into the KISS cost drivers, and enables you to make faster decisions and makes much more tool cost calculations in the same time, yeah. Then is design to cost. Here I can use my own cost model, so that I just need to open the frame, and let's imagine I'm a designer, yeah. So basically what I will do here is that I extracted all these parameters from this frame, yeah, and I just want to do the minimum inputs possible. So I just want the tool to calculate the cost for me, yeah. So I open the cost model built by my own company, yeah. So basically I have here an aluminum extrusion cost model where all the yellow parameters is the geometry data from PCM. The white cells are formulas, any formula, and the green cells is the exported back data to PCM. All the machine prices, all the material prices still remains in PCM. We use this cost model to use the formulas, yeah, that can be reduced, and the full BOM will be calculated here, right? So we just click import, and the full cost is calculated. Yeah? So basically, what we did here is a cost calculation, and right here I can just change some parameters and see all this that I can re-import and see what is the change in these parameters I've done. Oh, if I increase the length 200 millimeters, there is a 20% increase in price. So all this enables you to create your own cost models and leverage this information faster. So for these, I can also show this how to reuse a path. And here, if I just put a path number that was previously calculated or was from my ERP, I have here the full calculation from my from the design is a lookup, yeah, and I need to speed up because time goes fly. Also, I can open the break and change a cost factor, yeah. So here I'm in supplier A, and if I double click to my supplier, I can see in green I have all my supplier agreed rates, and I can double click to my supplier, right? And I can see all my cost factors from my supplier in one single view. Yeah, this is new from latest versions, and I can change here my suppliers agreed rates. Yeah, and basically change it. I put the 6. Yeah, and update my calculation then later. And I even can do a mass data change from cost factor rate. Yeah, so here what I can do is I can say, okay, what if my prices increase 10% on electricity and 10% more on the German skilled worker? Yeah, so that I can see the effect in the total price. So this is just some capabilities that I have. Yeah, integrating the full relocation. So obviously I have the capabilities to build my own cost models. Yeah, to drive through knowledge database up-to-date market data. Therefore, the company is not dependent always on search performance. Yeah, the designer is capable of changing parameters, not only based on design, but also based on cost factors. Yeah, and there is no need to question about the calculation metrics. Yeah, this is always a verified data source, right? So we'll jump into the profitability. Yeah, very quickly. This is the final 2 videos. So we open the project and we see all this profitability template landing page, where here we set up the EOP and the SOP dates, yeah, where we have the mountain bike net sales price that we calculated. Yeah, we have the annual requirements. We have the setup year by year, right? We have the measures, risk and opportunities. In this case, I didn't put anything. The special direct cost for the development cost, yeah, like CAD design hours. Then I introduce hourly rates. I have my dedicated investments, like for machines and tools. And then I have my contribution margin calculation, yeah, which is based on what has been calculated from the product costing. And then I calculate my contribution margin 1, and then I take the development cost and tools, and then I have my contribution margin 2. And then I set up my profitability. In my profitability, I have my all my quantity progression, what I can simulate, and I can just go to my dynamization, where I can just go through the net sales price costs, material price, evolving direct labor, and then I have my overhead rates like evolution. Yeah, so my G&A goes up on, and my production working capital. Yeah, for terms of payments or suppliers, these costs which are not considered in the path cost, for example, and then we have the profit and loss. This is totally configurable for each customer need. Yeah, where we have the price, sales price evolution on all the P&L evolution. Yeah, and then obviously the cash flow, and we have the KPIs. So for the KPIs, here I show 4, but many other can be triggered. And of course, the big benefit of this, especially in these times, is that we can just simulate all the quantity change. What happens if my volume drops 20%? Should I still be profitable, or I still have 20%? What happens if instead of 6 years drops down to 4 years? Yeah, so I can see here my profitability impact, right? So this allows you to do faster simulations, yeah, and avoid unprofitable business, yeah, and obviously reduce a lot of manual work, and you can link this to BI. And last but not least, the export of cost breakdowns. So this is a very simple tool, a magnificent tool that I have here, a 91-cent part calculated, as we have done before. I will speed up this because we're running out of time. So I can export this calculation in any template. I show here my demo Siemens template, which worked fantastically well. Yeah, and I can here change some parameters in the profitability in the manufacturing. For example, instead of 34 seconds, I switch it to 60. I change my machine hourly rate. I change some material prices. Yeah, where I can simply import it back. Yeah, and once I import back the cost breakdown, I can do a delta simulation. Yeah, here it will show now I have a break with CVD import, export example, and I can just grab these two and do a traditional report, comparison report, comparing, oh, there is where are the changes from me and my customer or my supplier. Yeah. So all these can be done with the tool. Sorry that I've been over time a little bit. Yeah, allowing a 80% time savings, offer formats already existing OEMs such as Daimler, Volkswagen, General Motors, and BMW. But other cost breakdowns templates can also be available as a service solution. Yeah, and reach supplier offers in the form of cost breakdowns. And you are able to compare multiple supplier offers at the same time in very detailed level. Yeah. So for these, we'll go directly to the last slide. Yeah. Obviously, this is not us, but our customers that saying this. We have more than 350 references now in the market from last year, counting that in NPDI you can save up to 20%. Yeah, you can work much faster, and you can ensure your profitability and share knowledge in multiple departments. Yeah. Because of this consolidated system, it reduces complexity of cost, enabling multiple departments to work in the same solution. So thank you very much for your attention, and sorry